All right, due to the popularity of these phase shift word problems, I'm going to go ahead and do another video for you guys. So the lowest temperature is usually around 3 degrees Celsius, and the highest temperature is around 18 degrees Celsius. The temperature is typically halfway between the daily high and the daily low at both 10 a.m. and 10 p.m., and the highest temperatures are in the afternoon. So halfway, this is talking about our midpoint. So halfway is that midpoint, and so notice that midpoint's at 10 a.m., and then the highest point in the afternoon, so you can think the afternoon is between 10 a.m. and 10 p.m. Think about that. 3 p.m. would be the afternoon. So that means from that midpoint, it's just going to be going up and go to the lowest. So we kind of have this cosine curve, but since they're actually giving us 10 a.m., they're giving us that midpoint, that where the midpoint occurs. I'm actually going to roll with sine and use this as my start. So I'm going to use that midpoint or midline point that occurs at 10. And I just got to double check. This is kind of where I messed up earlier on that one tutoring session earlier. But T is hours after midnight. So 10 a.m. would be 10 hours after midnight. So we just have to pay attention to little details like that, because that's the kind of stuff that can get us in the end, as you saw what happened to me earlier. So midline, well, we have our min. We know that our minimum is 3 degrees and that our maximum is 18 degrees. So in the midline, they didn't give us the midline value, but we could figure it out by averaging the two. It's going to be right in the middle of those two. Think about that. The highest right here is 18. The lowest would be 3. So what's the number between those? So I'm going to take those, add them up, and divide by 2. So that's going to be 21 over 2, or 10.5. All right, so now that we know our midline, and since we're starting with that, we're going to really be using sine. So our midline is 10.5, so D's already taken care of. It's 10.5. Also, our shift, which is C over B, has been taken care of. It's 10 to the right, so let's put 10, right 10. In the end, it should be minus in our equation because it is to the right. And then our amplitude, let's go ahead and come up with our amplitude. Our amplitude is the distance from the maximum to the midline. So if you want to picture that, the distance, our maximum to the midline, and our midline is at 10.5. So that would be 7.5. 18 minus the 10.5 would give us that distance there, which is going to be 7.5. Don't really like that, 7. So once again, just to show what's going on here, we're here at 10 and 10.5. That's going to be our midline point, and we know that it's going to be increasing from there because it goes to the highest temperature in the afternoon. That highest temperature is 18. Then it comes back down. So that's what we're modeling right now. I mean, eventually it's going to come back up. So let's figure out the period. So the period here would be, I'm guessing 24 hours, because we're talking about that it's a daily thing that's happening. So this is something that just is periodic based upon the day and keeps repeating itself throughout the day. So our period is going to be 24. So we're going to do 2 pi over b equal to 24. So 24b equals 2 pi. So b will equal pi over 12. So putting this all together, we're going to have 7.5 sine of pi over 12, then the parentheses x minus 10, so that way we shifted it to the right 10, plus 10.5. And that should do it. So notice something, this is in radians, so that's important for our next part. So that's part A. This right here, let me just drag that over, is going to go right in there. So that's our equation. That's for part A. So what is the temperature at midnight? So what we got to do, midnight, well, how many hours is that? How many hours is that from midnight? That's really just 0 when time is 0, right? It's been 0, or you could put in 24. It is periodic. Those should give you the same answer. I'll actually try it out just to see, to make sure. So for this one, we're just going to really just take that. Oops, and notice I put x there again. I keep making that mistake. That should be t. So we're going to have t of t is 7.5 sine of pi over 12 t minus 10 plus 10.5. So remember, what does t even represent? Little t, well, big T is the temperature, little t is the hours after midnight. So what is the temperature at midnight? Well, how many hours is midnight after midnight? That's just 0. So we're really finding t of 0. 7.5 sine of pi over 12 times 0 minus 10 plus 10.5. So I'm really just plugging that 0 in. That's all I'm doing to figure out the temperature after midnight. Like I said, 24 should give us the same thing because this is periodic behavior. We'll double check that right now. So let me just pull up Desmos so we can do that. Got something here already. So let's see, 7.5 sine of pi over 12 times, times 0 minus 10 plus 10.5. And let me just double check that I'm in radians, and I am in radians. So that's something, the problem is saying that it's in radians. Should be more consistent with my highlighter color here, but it is in radians. So just be careful that you're in radians or degrees depending upon the problem. So 6.75 would be the answer for that. Like I said, I'm going to double check, put a 24 in here. It should give us 6.75, and it does. 48, so every 24-hour period, it's still coming back to that same temperature. And that's it.